Hello everyone, welcome to RN tutorials on engineering mechanics. So here the lecture 7 on finding the resultant of forces again. So here again another different example, that is forces of magnitude 10, 20, 30, 40, 50 and 60, total 6 forces acting from the center of the regular hexagon towards its 6 angular points. So find the magnitude and direction of the resultant force. So here we are going to find the resultant of the 6 forces which are acting at the corner points of the hexagon. So for that I want to show you the representation first. Okay, so like this the different forces are acting to the 6 corners of the hexagon as shown in figure. And so for these all forces, 6 forces, we need to find the resultant of these forces which will give the same effect as these 6 forces. So for that first we need to know the inclination of these angles with respect to the horizontal line. So for finding the inclination of these forces with respect to the horizontal line, we need to consider 360 degrees. So the angle between the two adjacent sides are obtained by 360 by 6. So here by calculating the 360 by 6, we'll get the 60 degrees angle. So that means here the angle between these two forces 60 and these two forces 60 and these two forces 60 and these two forces 60, not between 30 and 20, not between 60 and 50, only between these 30 40 40 50 20 10 10 60. So the angle between these two forces is equal to 60 degrees. So by calculating 360 by 6 we'll get these values. Okay, now so for finding the resultant force, we need to find first some of the horizontal forces and some of the vertical forces, because the resultant force is equal to square root of sum of horizontal forces and sum of vertical forces. So again already we know that we can resolve the inclined force into two components, horizontal and vertical, if the force is inclined. So if the force is inclined, we can divide it into two components. So based upon that we can have horizontal and vertical. So for that we need to take the sum of the horizontal forces and sum of the vertical forces. So here each force we need to take the horizontal component for all the 6 forces for finding the sum of the horizontal forces. So that is sigma h is equal to, first thing is we consider 40 newtons, 40 kilonewtons. So this 40 kilonewtons is already acting in horizontal line. So this 40 kilonewtons becomes the horizontal force which is acting on a particular body. Okay, so take 40 as first force, and next for 30 kilonewtons, this is acting at an inclination 60 degrees to this horizontal line. So with respect to this inclination we can form a horizontal component for 30 kilonewtons. So here the horizontal component of 30 becomes 30 cos uh, cos 60. So because horizontal is adjacent, horizontal force will be adjacent to the 30 kilonewtons. So the horizontal component of 30 becomes 30 cos 60. So 40 plus 30 cos 60, and here again why positive sign means here this force is acting in this direction, so the horizontal force also acts in positive x direction. So for that we need to consider positive sign. And next we have to take the horizontal component for 20 kilonewtons. Similarly, the horizontal component means here in this direction the horizontal component will be acting for 20 kilonewtons. So the horizontal component becomes again here 20 cos 60 degrees. So here we need to take the negative sign. Why? Because it is acting in a negative x direction. So negative, that means minus 20 cos 60. That is the horizontal component of the 20 kilonewtons. And the next force is 10 kilonewtons. This 10 kilonewtons is again already acting in horizontal direction. So the 10 kilonewtons only becomes the horizontal force which is acting on a body. So and again we have to consider negative because it is acting in negative x direction. Okay, so minus 10. Next, similarly for 60 kilonewtons we need to take the horizontal component. So for this force also horizontal component will act onto the 10 kilonewtons line only. So for this horizontal component again this inclination is given to this horizontal line only. So this will be adjacent side. So the adjacent side means this horizontal component of the 60 kilonewtons becomes equal to 60 cos 30. Okay, if it is adjacent, we'll get the cos only. And again negative we have to consider because it is acting in negative x direction, so minus 60 cos 60. And similarly for 50 also we need to take the horizontal component. So this horizontal component of 50 kilonewtons will be acting on a 40 kilonewtons line. So for that we are taking the horizontal component as 50 cos 60 degrees, that is positive because it is acting in positive x direction only. Okay, so like this for all the forces we have written the horizontal components. So sum of all these horizontal components will get the desired value of the horizontal desired value for the sum of the horizontal components. Here I am again writing the simplified values for finding the sum of the horizontal forces. Okay, so totally finally it becomes the value sum of the horizontal forces is equal to 30 kilonewtons. And next we have to find out the sum of the vertical forces. So after finding sum of horizontal we have to go for sum of the vertical. So for each component, for each force again we have to consider the vertical component. So similarly here for 40 kilonewtons it is only acting in horizontal direction, so no vertical component for this force. So next directly we have to go for 30 kilonewtons. So for this 30 kilonewtons vertical component we can write it as 30 sine 60. So it is plus 30 sine 60 because it is acting in upward direction. So sum of the vertical forces sigma v is equal to 30 sine 60. Similarly for 20 kilonewtons it is also acting in this vertical direction only. So this vertical direction, that is the vertical component of the 20 kilonewtons, we can write it as plus 20 sine 60. Why? Because plus means it is acting in upward direction, that is positive y direction only. And next thing we have to go for the vertical component for 10 kilonewtons. Here no vertical component for 10 kilonewtons because it is already acting in horizontal, so no vertical component can have. So here again we have to go for 60 kilonewtons, which is acting at an angle of 60 degrees. So it is having horizontal component means automatically it can have the vertical component in one downward direction here in this position. So the vertical component of this 60 kilonewtons can be written as minus 60 sine 60. Why? Because minus means here it is acting downwards, that is negative y direction. So that's why the vertical component of 60 kilonewtons is the 60 sine 60. Similarly we need to write the vertical component for 50 kilonewtons, that is the last force acting on a body. So similarly it will be also acting in downward direction, so that's why negative sign, sorry, so again negative sign we have to consider negative, that is minus 50 sine 60. Why? Because it is a vertical component, so we'll get minus 50 sine 60. Okay, so by simplifying these values we'll get a certain value that is equal to sum of the vertical forces. Okay, sum of the vertical forces will get the value as minus 51.96. so the negative sign we are getting because the negative values we are getting larger, so we got minus 51.96, that is sum of the vertical forces. Next we have to go for the resultant force, that is equal to square root of sigma h square plus sigma v square, that is square root of uh, sum of the horizontal forces square plus sum of the vertical forces. So square root of sigma h square plus sigma v square, substitute the values here, r is equal to square root of uh, 30 square plus minus of 51.96 whole square. So by simplifying this we'll get the value as 60 kilonewtons. So it is not visible, so the answer is here 60 kilonewtons, that is the resultant force which is acting on a body, which will produce the same effect as all the six forces acting on a particular point in a direction which are acting towards the corners of the hexagon. Here he has given the condition that is the forces are acting to the corners of the, that is to the six angular points of the hexagon. Why? Because means for finding the angle between the adjacent two adjacent sides of the two adjacent forces in the problem. Okay, so for finding the angle only he has given that relation. So for finding these angles, that is angle between two adjacent sides, we can take 360 by 6 degrees, then we'll get the angles as shown in figure, that is 60 degrees. Okay, so I hope you understand again how to find the resultant forces acting on a body by finding the horizontal component of all the forces, by finding the vertical component of all the forces, and by taking the sum of horizontal forces and by taking the sum of vertical forces, we can find the magnitude of uh, resultant force. Okay, so the direction means here we need to find out the theta angle ma. So how can we find out the theta angle means tan theta is equal to sum of vertical forces by sum of horizontal forces. Then we'll get the theta is equal to tan inverse of sum of vertical forces by the sum of horizontal forces. So by that we can also find out the theta, that is the direction of the force, that becomes the direction of the force. So I hope you understand. uh, if you still have any doubts, feel free to give a comment to my video, and don't forget to subscribe to my channel. Please subscribe to my channel. If any topics you needed, please give a comment, or you can send a message to my mail id. Okay, so thanks for watching my video again. Thank you all. Thank you so much.